So polynomials are really, they can be broken down. But before we do that, I want to remind you guys, some of you guys are what we call new math kids. And, well, actually, all of you guys are. So I want to show you guys how to do long division, because long division with numbers is the same as long division with polynomials. And so the way that we do long division is we think of this number 32, and then we look at the number 3. How many times does 32 go into 3? 0. How many times does 32 go into 35? Once. So if I put the 1, I'm going to put it over to the 5 because I'm going into 35. 1 times 2 is 2. 1 times 3 is 3. Now when I multiply them together, I then subtract whatever I've multiplied. So I multiply 1 times 2, which is 2, 1 times 3, which is 3, and I subtract 32 from this. Now I have a remainder of 3. What do I do next? Bring the 8 down. So now how many times does 32 go into 38? Once. So 1 times 2 is 2. 1 times 3 is 3. Now that I have the product, I subtract the product and I get 6. What do I do next? Bring down the 7. How many times do you think 32 goes into 67? Twice. Now 2 times 2 is 4 and 2 times 3 is 6. Subtract them and I have a remainder of 3. Now there's a couple of ways that we could address the remainder. We could write it as a fraction or we could just leave it as a remainder. So 2 ways to write the answer is we could say 1/12 with a remainder of 3, or we could say 1/12 and 3 over the divisor, which is 32. Both of those are the correct way to represent the answer to this division problem. Okay? Now, how do we do that with something like this? Example number 1 says, take 2x to the 4th. Actually, I'm going to need more paper than that. They want us to take 2x to the 4th minus x cubed minus 2 and divide it by 2x squared plus x plus 1. So that means I'm going to take 2x squared plus x plus 1 and divide it into 2x to the 4th minus x cubed. Now here's a little trick I want to show you guys. When you look at this term, how many x squareds do you see? 0. So I'm going to say plus 0 times x squared. How many x's do you see? 0. So I'm going to say plus 0 times x. And then we say minus 2. Now, what Mr. Adams wants you guys to realize is that it goes a lot easier if we represent each power of x, whether it's listed in the problem or not. How do we do that? We write down 0x squared plus 0 times x. Now we solve this problem the exact same way. What do I multiply x squared by 2x squared to get 2x to the 4th? X squared. That's it. So I'm going to write down x squared. Now I'm going to multiply x squared by 1. What is that? X squared. So I'm going to place that over here by the x squared. What's x squared times x? X cubed. What is x squared times 2x squared? 2x to the 4th. Now what did I do when we did the long division problem? At this stage, after we multiplied the product, what did we do next? We subtracted. So I'm going to subtract that, and subtract that. Now what's 0x squared minus x squared? Negative x squared, right? 0 minus 1 is still minus 1. What's minus 1x squared and another minus 1x, or cubed, and another x cubed? It's negative 2x cubed. What about these? What do these do? They cancel out. Now I start over. But wait, before I start over, what do I do? I've got to drop down my 0x. What do I multiply 2x squared by to get negative 2x cubed? Negative 1x. Is that right? So now what's negative 1x times 1? Negative x. What is negative x times x? Negative x squared. What is negative x times 2x squared? Negative 2x cubed. Now at this point, what did I do? Subtract. Now when I minus a minus, what does it become? A plus. But I've got to remember to minus a minus on every term. So at this point, instead of thinking subtract, what you do is you change the signs. If it's positive, it then becomes negative. If it's negative, then it then becomes positive. Does that make sense? You're really doing what we call the additive inverse. So now I've got 0x plus 1x, which is x. I've got negative x squared plus x squared, which is 0. And then, so these cancel and these cancel. Now what do I do? Bring down the negative 2. Now, can 2x squared go into x? No. This is our remainder. Now, how could I write that? Well, I could say that 2x to the fourth minus x cubed minus 2 divided by 2x squared plus x plus 1 is equal to x squared minus x. Now what do I do with the remainder? Put it on top of the divisor, which in this case is 2x squared plus x plus 1. Does that make sense? So let me recap this. I'm asked, what is this divided by this? Okay, so we say, what is this divided by this? Then we write it up like a long division problem. Then we follow the algorithm for long division. When we're done, we're left with a remainder. To write my solution, I can write this portion down plus the remainder over the divisor. Does that make sense? So sometimes we'll have a remainder, and that will be written over the divisor. Does that make sense? Okay.